Y2k? Well, here's Y2k times 2, or better known as Y2k38 for 2038. Open source communities trying to tackle the Y2k38. These communities, such as openSUSE, have been working on the Y2k38 issue. We have 12 years that remain before a fundamental limit in timekeeping threatens to disrupt unprepared computer systems. Y2k38 is the new Y2k, and open source contributors are aiming to create actionable warnings. Communities such as openSUSE, known as the faulty date logic, which is more common in computer systems than people may think. openSUSE is actively surfacing and fixing these issues through early testing, toolkit improvements, and community-driven contributions to ensure software remains reliable and working beyond 2038. While most see this as an issue of mainly 32-bit platforms such as i586 or ARM v7, there are some exposures with modern 64-bit systems covered in openSUSE conference talk some years ago. Y2k38 is close enough to force action, and recent testing by openSUSE developers demonstrates that the risk is immediate and tangible. By advancing a build system's clock into 2038, numerous packages failed to complete and pass their test suites. Affected software and tests include version control tools, editors, compilers, Python libraries, desktop toolkits, and system components. In some basic systems behavior, like uptime, was disrupted. In some cases, system behavior, like uptime reporting, was disrupted. Several of these failures have been corrected, but breakages in these tests show how deeply embedded 32-bit time assumptions exist. Each new feature or refactoring carries the risk of reintroduction. The problem if developers default to using int or long. Instead, safer types such as timet, int64t, or long will work better. The problem extends beyond applications. Commonly used protocols, including SOAP, XML, RPC, SNMP, encode timestamps, and 32-bit values. Implementations must therefore take extra care to handle dates beyond 2038 without breaking interoperability between the system, applications, or desktops. Testing stealth remains challenging. Tooling improvements are being explored as a next step for these adjustments. Discussions are underway about adding compiler warnings when code performance unsafe conversions between 32-bit integers and time-related types. Stop using 32-bit, go to 64-bit integers. Leap 16 is 2038 safe and is common, and as it comes with 32-bit support disabled by default, but the tests show that changes in the future minor releases will be needed to fix additional issues in the future. So if you're a developer and want to help out on openSUSE and Linux, please go to the openSUSE mailing list and sign up. If you like this content, please like and subscribe. openSUSE is here to help the Linux community.